Okay, here's video number 8 in the series for reviewing the SRT standard. Look, there's the disclaimer. I don't have the energy to say it all. I'm sick, sorry. Okay, here we have graphically, this is asking you about all these functions. Are they even or odd? Okay, this is a big time concept question about which functions are even or odd, and it's right there. Okay, we know cosine and its reciprocal has to be even. Why? Cosine is the green function. Remember what what even means. If you plug in a negative value, it spits out just the original function. So let's look at that. Let's look at, I don't know, let's look at 3 pi over 2 and negative 3 pi over 2. I'm just telling you right now, I know no, this is negative 1. This is pi, sorry. That's pi, and that's negative pi. Again, poorly drawn. Cosine, the green, is negative 1 at pi, but at negative pi, you see how the x value plugged in right there? If I change the negative, look, it's the same fat value. That's how I know it's even. Another way you know it's even, if cosine functions are even if they can be flipped, reflected over the y-axis. Look at the green function. If you reflect it over like that, that's how you know it's even. So cosine and its reciprocal secant are the only functions of the 6 that are even. The others are odd because they're a 180-degree rotation around the origin. So look at the yellow function, which is the sine curve. Okay, if you can see it, remember, just think if you twisted that 180 degrees around the origin, it's going to be the same function. The same thing with tangent that goes through the function. The red one, if I twisted it 180, tangent is also odd. So, going up here, if you remember, cosine and secant are even and the others are odd. Which one of these is true? Secant's not odd. Cosecant's not even. Cosecant is odd. Secant is even. Select all that apply. So in this case, it'd be C and D, because cosecant is odd and secant is even. Okay? Any questions on that? Okay, we're going to get right into this problem right here. Angle of depression from the start of a 6-foot high access ramp. I drew a diagram down here. This is the 6-foot high access ramp that ends 40 feet away. So it ends 40 feet away. Okay, that's the question up here. 40 feet away along the ground. Oh. So the question is the 40 the hypotenuse, or is 40 this one up here? I don't know. Because this one is sine. This is one you've never done before. I was assuming they'd set up a different problem, because if the 40 was right there, that's just the Talisa shadow problem in reverse. Just use inverse sine to find the angle. Either way, we need to find the angle of depression. We're going to do it this way. I'm not sure it matches this this diagram right here, but the long and the short of this is, boys and girls, you got to be able to accurately draw a diagram. I think along the ground is the hypotenuse right here. So we set up sine of alpha equals 6 over 40, and we just do inverse sine of that fraction, second inverse, and I'm just going to put the fraction right in there. 6 divided by 40. Boom, 8.6 degrees. Doesn't say what to round to. Okay, any questions on that one? Sweet.